Struggling on the solubility rules to get those memorized, then what you should do is like maybe right before the test, write them down a whole bunch of times, and then right when you get the test, write it down on the exam. That way, eventually, you want to get those in your longer-term memory. But what were the solubilities rules again? Good.
Nitrate and acetate anions soluble.
Okay, nitrates, acetates, and chlorates. And chlorates. Nitrates, acetates, chlorates are soluble. But that's good. I mean, that's the bulk. Keep.
Carbonate, chromate are soluble with group 1 and 1.
Yeah, well, you want to go through the sequence. I mean, there's a certain pattern to it as far as, we start off with group 1 and ammonium. Group 1 and ammonium are all soluble. And then it goes nitrates, acetates, chlorates are all soluble. And then it goes chlorides, bromides, iodides are all soluble except for and mercury. And then it goes sulfates are all soluble except for silver, lead, mercury, calcium. Well, actually it goes silver, lead, mercury, mercury. Mercury meaning mercury 1, mercury 2. Calcium, strontium, and barium. Good. That's why we went through the pattern, because it goes chlorides, bromides, iodides, except for silver, lead, mercury. Then sulfates are soluble except for silver, lead, mercury, calcium, strontium, barium. And then what? Then we shift now. We shift from the soluble ones to the insoluble ones. And then we'd start off with the hydroxides. What were the hydroxides?
Insoluble except for group 1, ammonia, calcium, strontium, barium.
Good. And then after hydroxides? Sulfides. Sulfur is just S. Sulfides has 2 minus. Sulfides are all insoluble except for and then what?
Phosphate, chromate, carbonate.
Phosphates, carbonates, chromates.
Insoluble except for group 1 and ammonia.
That's it. That would be it. And so you want to have those memorized for tomorrow, or at least in your short term, so you can write them down. I think when I was learning the solubility rules, that's what I did. I was still working at getting those memorized. Didn't want it to occupy too much brain power, so right when I got the test, I would write it down, all of them, just automatic. Try to do it quickly, and then you can forget about it. So the homework is kind of complicated because the homework is mixed. There's going to be problems from the chapters 8 and 9 that aren't due for this test. The reason they aren't going to be due is because we're skipping some of that stuff for this particular test. So let's go through it. So we kind of left off with the gases part. We didn't completely finish the gases for the last test, correct? Or did we?
Yeah.
We finished it completely? All right. So then that means we are with nomenclature, chapter 6, chemical formula relationships, chapter 7. So this and this are going to be completely due. How about the nomenclature lab? Have you guys finished that one? I know some. You don't have to finish everything because electron configurations, that's something we'll talk about later. But chemical reactions and chemical change. Okay, so let's take a look at the chemical reactions. And let's see the problems that I assigned. What were the problems I assigned on chemical reactions? Does somebody have the numbers written? For chapter 8? One, 7, 9. One, this is just balancing. 1, 7, balancing. You know, that kind of balancing stuff is fun. So this is writing equations. They give you this is an exercise in just nomenclature, basically, and balancing. It's no you know, here you don't have to predict the products because they tell you what the products are. So those are okay. These, again, just more. I mean, pure hydrogen iodide decomposes spontaneously into its elements, hydrogen and iodine. So here we don't have to do any predicting. So you might have something like this. Those are okay. 8, calcium reacts with hydrobromic acid. Magnesium is placed in sulfuric acid. So problems 19. Okay, 19 through 22 is what we call single replacement reactions. So I decided I'm not going to do single replacement reactions for this test. We'll do those later. So 19 and 21, you don't have to do those. 19 and 21 for this test. 23, 24, all these are what we call double replacement reactions. So 23 through okay. 23 through 32 are what we call double replacement reactions. So you should do those. 33 is a combustion reaction. It just reacts with O2 to form CO2 and water. This is another combustion reaction, reacting with oxygen here to form CO2 and water. So it's just balancing. Sulfuric acid decomposes. So they tell you what the reactants are and what the products are. 38 is single replacement. Did I do that one? 37. 37 single replacement.
Are we doing that?
No. 37, don't do. 39, don't do. '37 and 39 are single replacement. Are you guys writing these down? Am I recording this? I'm recording. 41 is a double replacement. 43. 43 is just a balancing and formula writing. They tell you what the reactants are. They tell you what the products are. 43. 45 is a balancing and nomenclature problem. 47 is combustion reaction. So on a lot of these problems, they tell you what the reactants are and they tell you what the products are. So all you have to do is write the correct formula and balance the equation. So you might have a problem like that. Okay, 51. Potassium hydroxide reacts with zinc chloride. 51 is double replacement. 53. Again, here they tell you that we take ammonium dichromate, and this decomposes into solid chromium 3 oxide, nitrogen, and steam. So here, you don't have to predict anything, you just have to write the formulas. Balance. 53, 59. Sulfuric acid is produced when sulfur trioxide reacts with water. Same. 61. Solid oxide of iron. 63. Did they tell you the products of 19? Let's see. They expect you to predict the products for single replacement and for double replacement. The single replacements will skip. So the ones that tell you the products were okay. 59 is okay. 61 is okay. 63, okay. 65. Okay. 69. 71. A is single replacement. So A plus BX. B is double replacement. Do that. C is a combustion. Combustion just forms CO2 and water. D is a double replacement. E, I think they're trying to do a decomposition to the elements lithium and bromine. F is double replacement. G is an element plus element combination. H is a single replacement. I is double replacement. J is a single replacement. Copper plus nickel. They should write the states here. I don't know why they don't do it. 69. And so single replacements will skip. A, I'm going to skip. G will skip. H will skip. J will skip. $71. 71 is the acid base. Talk about that. Okay, let's take a look at Chapter 9. Next, get back to okay, 5 through 12. So chapter 9, 5. This is solubility. Through 12 are just soluble. Which ones are soluble? So those are okay. 17. Let's take a look. Right reactions. Okay. So for 17. Potassium nitrate, solid precipitate of silver phosphate form when silver nitrate and potassium phosphate are mixed. 19 is double replacement. 21 is single replacement. 21, skip that. 23 is a single replacement, skip that. It's 25. 25. What do you think these combustion ones? You want those on the test? No? No combustion? Alright. How about the element plus element combination reaction? Element plus element combination? In the test? Alright. But you don't want the combustion ones on this test. You want the combustion ones on the next test? Yeah? We could put the combustion ones on the next test. There are a lot of combustion ones here. These are all
So do we
combustion.
skip for chapter 9 because we skip all discussion? We're gonna have it.
Chapter 9, we have to have these ones here. These ones are the most important for chapter 9. These are the double replacement reactions. So 29, 31, 33, 35, 37, 39, 41, 43, 45, 47, 49, 51, 53, 55, 59 are double replacement reactions. Okay, 61, aluminum is placed into hydrochloric acid. 61 is a single replacement. 61, skip that. 63. 63 is a double replacement reaction. So 63 is okay. Do that. So skip 61. 65 is double replacement. 67 is a single replacement. So skip 67. 71 is a double replacement. Do 71. 73 is a single replacement. Skips 73. Okay, did everybody get those? Okay. Those are for the test. Those are the ones that you want to do for practice. Now, what I want to do though is I want to collect the homework all at once, and I don't want to do it in two parts. And so for chapters 8 and 9, just turn those in complete with the next test. 8 and 9 complete with the next test. But one of the problems that you want to do to help you for this test are the ones that I mentioned, the double replacement ones, and element plus element combination. And so we'll have two types of reactions on this test. On the next test, you're going to have many types of reactions. We'll have, for this test, let me just write it down here. So, for exam 2, we're going to have this redox. Element plus element. Like for example, magnesium plus oxygen yields magnesium oxide. Magnesium solid plus oxygen gas yields magnesium oxide solid. Element plus element combination, or we could have a decomposition. Element plus element yields compound. or the compound can decompose into the element, which is just a reverse reaction, which is the MgO solid decomposes into MgO solid plus 1/2 O2 gas. Or I could double everything here. But like, alright, that's redox. We're only gonna have one type of redox for this one. That would be the element plus element. I was thinking of putting combustion, which would be the next type of redox that I might have on that. But I'm gonna skip it this time.
Can you explain the 1/2 oxygen or the 2/3 oxygen?
Well, it's just for balancing. I have one magnesium, one magnesium. I have one oxygen here. I have two oxygens here. So I could take two oxygens and cut it by half to give me one oxygen, or I could double everything. I could just do two magnesiums, one oxygen, and two MgOs. You know, I could double. The reason why we leave fractions sometimes is because we want, you know, 1 unit of MgO decomposes into what? Okay, so 1 mole of MgO decomposes into 1 mole of magnesium and a half mole of O2. So sometimes we'll put fractions in there, sometimes we'll leave the fractions out. You don't have to use the fractions. You could just double it, which is fine. Just double it. And then for metathesis, we're only going to have one type of metathesis react. Well, maybe. Metathesis, you know, you should know, but for sure you should be able to do the double replacement pattern, AB plus CD. You should do the CE, the IE, and the NIE plus driving force. Metathesis. We'll just start off simple right now. Next test will be a more complex. This is one of the biggest patterns you should be able to recognize. The format for the test might be similar, might be different here. I haven't decided yet. Well, the first part was just writing formulas for our items here. Something like that will be on this test. Write the formulas for the compounds. This is nomenclature. Name the compounds. Nomenclature. Four is just talking about reactions. We should know oxidizers. Even though we aren't going to have single replacement, this element plus element, you know, which one's the oxidizer here? So magnesium goes from 0 to 2 plus, oxygen goes from 0 to -2. Which one's the oxidizer? Oxygen. Magnesium is called reducer. What do oxidizers want? Electrons. We call them electron poor because they want electrons. I'm behind this semester compared to last time. So I'm pretty far behind. So this one I haven't talked about yet. But what would you expect? You know, it's neutral, but would you classify it as electron rich or electron poor? Reducers are electron rich, oxidizers are electron poor. So methane is electron rich or electron poor. Well, I don't know how much you guys have been. I did mention this in class, but probably don't remember it. Reducers are also called fuels, and so one thing about fuels is, you know, they can burn. You can burn fuels. fuels are reducers, they gotta have an electron, they gotta be electron rich. And so like methane, does methane burn? Yeah, methane burns. So, based on what we observe, methane's easy to oxidize. You can burn it quite easily, it makes a nice flame. Metals are a little harder to burn, but you can burn metals also. Some metals are actually marked flammable. I don't know if I mentioned this earlier. Like magnesium. Magnesium was quite flammable. Do you remember the magnesium burning in air? How bright that flame was? Yeah. It burns quite nicely. It gives a very bright white flame. Emits a little bit of UV light too, so you got to be careful with it. And so methane, just based on physical, the physical connection, with fuels and burning is it. But there's another thing we can easily tell about methane. That is, what's the charge on hydrogen in methane? If we're the charge being the oxidation state, it's not really charged. It's not an ionic compound, but what would its charge be? This is for bookkeeping. This is a molecular compound, not an ionic compound, but its charge would be what on hydrogen? +1. Which means carbon is, each hydrogen's +1, so H+, 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 and then carbon has to be what to add up to 0? Carbon has to be -4. -4. That's as rich as carbon can get. If we look at the periodic table, what does the charge on carbon vary? What's the range on charges in carbon? If you look at the periodic table, carbon can vary from, group 1 is what? +3, +4. So carbon can go up to +4, or it could go the opposite. This is -1, -2, -4. And so carbon's charge varies from +4, in which it would be electron poor, all the way to -4, in which we call it electron rich. And so this carbon's quite electron rich because it's at the -4. It's as rich as it's going to get, basically, at -4. This is why methane burns so nicely. It's a great fuel. It's electron rich. Like metals are electron rich. Metals can burn. And so number 4, what did you put down here? True. That's correct. Number 5. True. Number 6. I didn't talk much about it, but this is true. This one will be, I'll just reserve this for the next exam. We haven't talked enough about redox properties yet. We just started. With the redox properties off the table. But what we have to do is we have to go beyond that table and be able to predict things like methane, that type of stuff. That's what I mean by going beyond, is looking at the patterns in that table and then trying to understand those patterns and applying them to other systems. So this was the next level, type problem. Is methane on that redox chart? No, it's not, but it would be a pretty strong producer if it was. 7. Element plus element combination, decomposition, single replacement, and combustion reactions are a redox reaction. That's true. 8. Titanium 4 ions and sulfate ions will precipitate. False. Sulfates are all soluble except for silver, lead, mercury, calcium, strontium variants. It's not going to precipitate. The oxidation state charge on chlorine in, what's this ion called? Perchlorate is plus 7. Plus 7, is that as poor as chlorine can get? Let's see. Is that as poor as chlorine can get? You tell me. Or can chlorine get even poorer? Plus 7 is pretty poor because plus 7 means that how many electrons did it lose? 7. Is that as poor as it can get, or can it get poorer? It's as poor as it can. How did you tell, Matt?
Because those halogens are in the seventh row.
Yeah.
On the left.
Right, so if we just continue, we said plus 4, plus 5, plus 6, plus 7. Plus 7 is as poor as it's going to get. So perchlorate's where it stops. There's no such thing as perchlorate. You know, because we went from chlorate to perchlorate to, is there a perchlorate? No, because it's as poor as it's going to get. And so perchlorate is, it's pretty poor, electron poor. Perchlorate is a strong oxidizer. Chlorate's a strong oxidizer because it's so electron poor. So we look at, well, I'm going to intersperse. We're going to intersperse some new stuff and some, because I don't want to fall too far. I'm already kind of far behind, but I don't want to fall too far behind. This is a dangerous compound. Ammonium perchlorate. This is pretty dangerous. Why is this dangerous? Because perchlorate, we classify that as an oxidizer or reducer. Is it electron poor or electron rich? Poor. So this is an oxidizer. But ammonium ion, ammonium, isn't that electron poor too? Ammonium, NH4 plus, because it's got a plus charge. So would you consider it electron poor? No, just like perchlorate. Perchlorate's got a negative charge, but we call it electron poor. Even the, you think, why is perchlorate electron poor? It's got an extra electron here, giving it a negative charge. Why is that electron poor? It's because where that negative charge originates from. Where that negative charge originates from is oxygen. So we have 4 oxygens and -2. Is oxygen happy with a -2 charge? Yes, it is. This is very happy. So that's fine. The negative charge just means we have an excess of negative versus positive. The chlorine's +7. I'll write Roman numeral this time. +7. You know, this is not an ionic compound. This is just how we visualize what's going on with the charges here. And so the electron poor part doesn't come from oxygen. Oxygen doesn't want to lose any electrons. It's not electron rich. This is just happy as is. It's a chlorine. So that's what's making this a very powerful oxidizer. How about ammonium? What's the charge on nitrogen and ammonia? Ammonia. In other words, hydrogen would be plus, you have 4 of them. So nitrogen must be, yeah, 3 minus or -3. For oxidation states, we usually put the charge in the front, like this. For just charged ions, we usually put the charge on the back. You know, -3 oxidation state on nitrogen, which means is ammonium electron rich or electron poor? How would you classify it? Well, you might think hydrogen. Ooh, hydrogen is electron poor, but it isn't. You know, we got to think water. When you look at water, what is water? Is water stable? Yes. Water is hydrogen's in the +1 oxidation state and oxygen in the -2 oxidation state. It's stable. That's because oxygen doesn't want to lose those and hydrogen is perfectly fine at +1 in this And so when I look at ammonium, is ammonium electron rich or electron poor? Ammonium is electron rich. Ammonium burns. Do you know you can burn ammonium salts? You can burn ammonium salts. They burn because the ammonium burns. It's a fuel. This is a dangerous compound because it's a fuel and oxidizer in the same compound. Usually we have the fuel as a separate thing. So the fuel is kept separate, like methane. Methane's stable as long as there's no oxygen. But if you start mixing, like methane's stable in the pipe here, we don't have to worry about it. But if you start mixing methane with oxygen, is that stable? No, because if I keep leaking methane into this room, I have a potential for explosion. You know, there's I think a 5-story apartment building in New York that was demolished by methane gas explosion recently. So this compound is dangerous because it has the fuel and the oxidizer in the same compound. Well, let's keep going here. Actually, ammonium perchlorate is very dangerous as well, too. I should show you this. I forgot the name of it. With the actual audio. This is really pretty interesting. This is called peptone. Maybe this is it.
Outside the city of Las Vegas.
I want the unedited original footage.
3 miles from town, 2 major explosions measuring 3.0 and 3.5 on the Richter scale ripped through the desert locale and sent visible shockwaves across a 10-mile radius. 2 people died. Over 300 people in the surrounding area were injured.
All right. That's ammonium perchlorate. It's pretty dangerous. He's a powerful oxidizer, powerful reducer. That's trouble. That's how poor chlorine is in perchlorates. It's pretty poor. Okay, number 10 is signal replacement, H+. It's a compound or ion reacting with silver. This is signal replacement. It doesn't look like that form, but it is. So number 10, skip that. Number 11, magnesium ions and hydroxide ions will precipitate. That's true. Hydroxides are all